welcome back. It's good to see everybody. Thank you. Again, I'll take back the old finals. Once you finish looking at them, you're welcome to look at them as long as you'd like. You can come back and look at them another day if you want to see them more, but eventually I do need to get them back. You can't take them home, unfortunately. So welcome back. Welcome to Calculus 2. Thank you very much. So I've given you guys a few handouts. We'll talk. Hi, come on in. Have a seat. So we'll talk about each of them in turn, but we'll begin with the real thick one, which looks like this. It's projected up here on the board. On the first page is something that I'm calling the integration formulas reference sheet. You're going to bring this with you to the tests. We'll look at it later on in the semester. The next page will look familiar to you if you took this course with me last semester. It was the old strategy guide for differentiation, no longer allowed on the tests, but I include it just so that you can be comfortable and have something that you've seen before. Certainly you can take a look at that as you are kind of shaking off the derivative cobwebs that may have built up over the last month or so. On page 5 is our Cliff Notes version of Calculus 1. You might take a look at that to, again, kind of refresh your memory some of the things that we looked at last semester. And we begin officially, I think it's on page 6. Yeah. Okay, so project number 1 is assigned. We'll talk about project number 1, but it's on the table, so make sure you grab something that says, "Have you ever seen the rain?" at the top of it. That is project number 1. And we begin here with number 1. And can we start with Maggie? Can you read number 1 to us, please? Thank you. Ernie, number 2. Okay, with your neighbors, you are going to pick the choice that you think is the right answer to that question. So start drawing, start talking, introduce yourselves if you don't know any names yet, and let me know when you've got an answer. Okay, so let's come back together. And we'll just run through the answers real quick. The answer to question number 2 is C. A lot of folks ended up drawing a picture that was increasing but concave up, not taking into account what? The wind resistance, right? And so that's why it actually looks like the blue one there. And then for the next question, speed became velocity, and the standard convention is that down is negative. The only difference between speed and velocity is the direction, right? And so we account for the direction by saying that the velocity is negative. But one of our groups actually said, well, you know, it's kind of arbitrary which way you decide positive velocity is. You could perfectly well decide to reorient your axes and say that positive is actually falling down, in which case the picture I think would look the same as it did in number 2. So that was a great catch. For the next question, local maxes only happen where the derivative is 0. That's not true. Could happen at an endpoint of an interval, for example. Could also happen at a place where the derivative is not defined. So absolute value, you guys know what it looks like. Flip it over because this question asks for a maximum point. Second derivative equal to 0 doesn't necessarily mean you've got an inflection point. You've got a candidate for an inflection point, but it was a little nitpicky detail that technically to be an inflection point, what has to happen at that point? It does have to be, actually it doesn't have to be differentiable. Yeah, it doesn't have to be differentiable. But what needs to happen on either side of the point? It has to have a change in concavity. Right, that's what an inflection point is. So it turns out x to the 4th is a counterexample for that one. People had great success with number 5. The process for finding critical points you know very well. Take a derivative, set it equal to 0. In this case, I think the answer is C, square root of b over a with a plus or minus in front. And then finally, number 7, finding a global max on a closed interval. Again, it's another process we discussed last semester. It involves finding critical points and endpoints, and then picking the winner. And I think it turned out the answer here was C. Okay. So let's take a look at something else. So also on your tables today was a copy of the syllabus. So make sure you have a copy of the syllabus. Part of your homework over the weekend is going to be to read through the syllabus. There's quite a bit of information there. We are going to spend less than 30 seconds talking about the syllabus because the vast majority of people sitting in this room right now saw almost exactly that syllabus last semester in Calculus 1, okay? So If this is your first time in a class with me, maybe some people around you can fill you in on some of the details of what are questions of the day, what is the homework, what is this business about grading options. We're not going to spend time because, again, it's something that almost all of you have seen already, okay? So there'll be time in this class today for people to kind of fill in the gaps for folks that for which this is their first class here. I just will point out the very last page of this packet of the syllabus is going to be something that we're going to look at just about every class. It's the calendar. You've got it there. The version that I'm going to pull up is always going to be this one here in Excel, but it's the same. And there's a lot of good information here, but basically it tells you the important dates of the semester, and it gives you information about the sections that we're going to cover today. We're reviewing 4 chapters, just talking about derivatives mostly. Tomorrow is going to be our review of the definite integral, and then we start in earnest in chapter 6. It also tells you the days of the quizzes. That's column C. Right, so tests and quizzes, and it tells you what the quizzes are on. This is the only place that tells you what the quizzes are on, so again, have that handy. It tells you when the projects are assigned and when they're collected, okay? Lots of good information on this. Again, we'll pull it up just about the start of every single class. All right, so as you can see here, project 1 is assigned at this moment. It is going to be collected on class number 4. So again, that means something to most of you, but at this moment, it looks like the 4th time we meet will be February 1st, but if we have a snow day between now and then, although technically I think it's too cold for anything to snow right now, but if we have a snow day and things get pushed back, the project will be due the 4th time you and I see each other in this room. That is something I can tell you. I can't guarantee it's going to be on February 1st, okay? So you have the project there. Make sure that everybody's got a copy of it. As usual, you're welcome to chat with each other. It's encouraged to work with each other on those projects. So make sure you take advantage of all the wonderful resources that you have in this room. Okay, any questions on any of those things? Okay, then we're going to come back to the packet, but before we do, just a couple of quick announcements. Number 1, there is a brand new graphing calculator rental program that GCC is doing, so if you have any interest in renting a graphing calculator, see me right after class. I can give you information. And here's the other thing. There are 2 sections of Calculus 2 this semester. This is the first time since I've been here that Calc 2 has been big enough to split into 2. So I think it's great that the administration has supported this split. That said, there are very different numbers of students in the 2 sections of Calculus 2. You guys are the big class. Last I checked, there were 23 people enrolled in this class. I don't know if that's exactly how many we have in front of us. There are 12 in the other class. So it's really quite different. I understand that there is maybe some motivation for taking calculus first and physics second if you are in those 2 classes, because the people that are in physics right now started at 8 and we started at 8:40. I get that. And for some of you, there's really no way that you could be here for your 8 o'clock physics class. But if there is any possibility to switch, please let me know. I'd really like to get the classes to be a little bit more close in size. So let me know. I can take care of all of the paperwork. You don't have to do anything other than say, hey, Ian, can you switch me? I'm in calculus and physics. Or if you're not in physics, but you're able to switch to the 1040 calculus class, let me know, okay? And it doesn't have to happen today. Let me know next week. It's easy enough to switch you. But I really would like to get them to be a little closer together if possible. Yeah, any questions on that? Okay, so let's go back up to here. So we're going to take a look. Here's a challenge problem. It's not something that we're going to spend time on in class, but I know that some groups sometimes finish the stuff in class very quickly, and so I've sprinkled throughout the notes these challenge problems to give folks something to do if they finish quickly. We move on to number 8. Okay, is it Dave? What's your name? Dave? David, can you read number 8, please?
Number 3 is how much is 1 plus 1 half? What is the
Thank you. Garrett, number 9.
Here's our quick review on derivatives. A was our original definition.
Okay, I'll give you guys a hint and then see how many of you can pull this thing out of a hat. This was the beginning of our original definition for derivative. See if you can figure out or remember or chat with your neighbors about what the rest of it was. What is the derivative? So we've got our definition for the derivative here. I'll even fill it in with our f prime of x in the front. Turned out there was another version of this that we might have mentioned. I don't know that we ever even used it, but there is an equivalent thing. Did we talk about this at all last semester? That look familiar to anybody? No, we really focused on the first one, and then once we had our derivative shortcuts, we stopped focusing on either of them. So I'm not going to ask you this semester to do this, but just want to give you a sense of like where we came from. That was our first intro to the derivative. And then we go to B, some of the interpretations of the derivative. Chris, what did you say? Slope of the tangent line. Good. Other interpretations of the derivative. Rate of change. I want one more adjective in the front of rate of change. Close. Tiffany? Instantaneous. Hello.
I'm sorry to interrupt, but I'm having problems. I hit something and everything I write is erasing, and I can't get my back, so would you help?
I will. Okay.
I erased it back. I think I hit a magic.
I'll come in just a moment. Okay, so come back to the interpretations. Can you guys work on this next part C? We're looking for a derivative in several different ways, given a table. On the next page, you'll see given a graph, and then finally, you'll see given a formula. So chat with your neighbors, see if you can estimate or calculate exactly the derivative in given 3 different things. Okay, so there's still going to be time in class for you guys to continue working on those derivatives, but let me grab you for just a few minutes here. So there are some changes that, well, some things I'm going to continue doing and some things I'm going to stop doing and some things I'm going to start doing, largely based on the feedback that I got from many of you on the last project of last semester. So things that are going to be continued here, we'll keep doing the projects. There's a lot of positive feedback about those. There are 8 projects throughout the semester. 5 of them are real world applications. 3 of them are, you know, more theoretical or just practice of technique. But anyway, based on your feedback, I'm really trying to up the percentage of real world ones. So that's a little bit higher for me than last time I taught the course. The frequency of the projects and the quizzes seem to work out pretty well for folks. I've taught courses where we had a quiz every single day. And it seems like the quiz about every week or so was a good tempo, and the same kind of thing for the projects. Also tried to make the quizzes worth a little bit more so that one little mistake didn't have as big a percentage effect on your grade. Grading options, somebody wrote amazing. I felt like I was reading like a New York Times review of some book or something. It was great. So, so the grading options are there. Again, if you're new to me, you can read and your classmates here will fill you in on what that means. Just to refresh your memory, you don't have to tell me how you want me to grade you until the day after I hand you back that first test. So you will have a lot of time between now and then, and you will have gotten grades on quizzes and projects and a test before you really need to commit to how you want me to weight things. I'm going to keep making videos. I'm making one now, and it'll be up on YouTube shortly. And I'll make videos for the sample test problems too. They don't exist yet, but they will before we get close to the sample test, before we get close to the first test. Group activity on most days. Some people wanted more, some people wanted less. You know, I'm kind of stuck here. I will say this, that even if it feels like you don't get quite as much done when it's group activity time as when I'm up here doing a problem from start to finish, it turns out that okay, so it's not really about how much we get done in class. It's about how much you remember. That's ultimately what's important. And so it turns out that, you know, actually doing stuff with your neighbors and explaining and hearing different perspectives from your classmates makes things far more memorable than when I'm up here doing my thing. So there's kind of a trade-off here. So it's not always about efficiency. We're gonna do probably about the same amount of group stuff as we did last semester. But if for some reason your group isn't working, talk to me, talk to your group, get up and move. I mean, you can sit anywhere at any point during the semester, okay? But I think the group dynamic is a really important one for us. So I want that to work. Going to continue to do the theoretical stuff as well as applications. attempting to lean towards applications. I know I don't always get there, but I am trying, moving in that direction. Okay, discontinuing, having a project due on the same day as a quiz. Several people said it was quite challenging to have a project due same day as a quiz, and of course there's homework due just about every day, and apparently you have other classes and responsibilities. Who knew? So I have made my original calendar had several projects and quizzes happening on the same day. I think 3 of them actually happened on the same day. I've changed it. We don't have any quizzes happening on the same day a project is due. Furthermore, I am, let's see, well, we'll talk about the homework policy, but you can turn stuff in late now. So, so hopefully that will ease the burden. Starting the challenge problems we've talked about a little bit. I expect some of you will have a chance to work on the challenge one from today because you'll finish those derivatives before the end of our class. Mixing up the groups is a suggestion several people made, and I think it's a great one. So I've got ideas. We're going to stay with these groups, but you can change on Monday and sit wherever you'd like. But maybe about every week, I'm going to try to force people to move around a little bit and get to know some more folks in the class. And you could end up finding somebody that you work really well with, or a group that you work really well with. Of course, it'll change in a week anyway, but I think it's a great idea to move folks around, so we'll do that. Okay, grudgingly accepting homework and questions of the day up to 1 week late without any penalty. And I say grudgingly because it's going to take me about 4 times as long to grade stuff when it's late as when it's on time, but I will do it. So if things are just piling up on you and you can't get stuff done exactly when it's due, don't sweat it, right? You have a 1 week grace period, but I'm not taking it after 1 week from when it's due, okay? All right, and I always think that I talk enough about how important proper notation is, but then folks end up feeling like, why did I lose points on this quiz or this test or this project? I didn't realize how important proper notation is. So I'm being very upfront. There is a higher bar this semester than there was last semester in terms of writing things correctly. So really focus on not having things float. When you write stuff down, don't let things float. If you're taking a derivative, put an f prime of x equals in the front. If you're doing an integral, we'll see them tomorrow. We're going to put a lot of integral signs in the front, okay? So really try to focus on good notation. If you don't know the notation, ask somebody. Like it's expected that you're going to be uncomfortable with notation that you haven't really used that much. The way to get comfortable with it is to practice with it. Ask your neighbors if it looks right. Ask me if it looks right, and push through. And then one thing I'm mulling over, but it probably won't happen this semester. A few folks talked about the possibility of makeup quizzes and tests. I think it would be great because it would encourage people to go back over things that they missed and learn them. And ultimately, that's the goal for everybody here, right? But logistically, I just don't know how to make that happen. So I'm open to suggestions. If you have thoughts, share them with me outside of class. I'd love to hear, okay? So retaking something you've already done, yeah. So doing corrections on it or taking a similar but different quiz or test, yeah. Okay. So again, I'm open to lots of ideas, but I did want to share with you that I read and took very seriously the feedback that you gave me last semester, and I have responded to it. Okay, so keep on trucking. You guys have about 10 minutes. That should be enough time, hopefully, to finish these 4 derivatives here. There are answers right there. And then the challenge problem, if you finish these early, is on the previous page.